Hello, and welcome to my presentation on Python for Data Analytics. My name is Tyler McDonough, and I'm an honors computer science student of Sinclair Community College. The purpose of this video is to share with you a data analysis project in my Python for Data Analytics course taken at Sinclair Community College. This course was taken in the spring of 2021, and it was professed by Professor Aparna Ramanathan, and the purpose of this project is to provide a detailed data analysis, report, and presentation for the Rhode Island Police Department on their traffic stop statistics. The purpose of this data analysis is to provide valuable information for the Rhode Island Police Department on their traffic stop statistics. Through this data analysis, we will ask and answer three key questions. What are the three most common types of traffic violations? Are males or females stopped more often? And rank the districts by number of traffic stops. To answer these three questions, we will analyze data from our data source, 91,741 records from Rhode Island Police Department traffic stops from January 4th, 2005 until December 31st, 2015. These records contain fields for the state of the traffic stop, the date of the traffic stop, the time of the traffic stop, the county of the traffic stop, the stop driver's gender, more accurately sex, the race of the stop driver, a broad categorization of the traffic violation type, a more refined categorization of the traffic violation type, if a search was conducted, the type of search conducted, the outcome of the traffic stop, if an arrest was made, the duration of the traffic stop, if the stop was drug-related, and the Rhode Island Police Department district that conducted the traffic stop. These fields are useful to pose and answer a wide variety of questions, but for our three key questions, the fields that we will focus on are the field for the more refined categorization of the traffic violation, the field for the stop driver's gender, more accurately sex, and the field for the Rhode Island Police Department district that conducted the traffic stop. When performing a data analysis, it is important to identify and disclose any assumptions made while developing the program or while analyzing data. For this project, assumptions include that the value case, lowercase or uppercase, of values in each field of the source data would be consistent, that value spellings in each field of the source data would be consistent, and that an unexpected error wouldn't occur during program execution. It's worth noting that these were not blind assumptions, but were judgment calls made after some early analysis of the data and its consistency across multiple records. Furthermore, because the data analysis was not running on server hardware or some other mission-critical computer, handling unexpected errors for these as-needed program executions was less of a concern as it would be otherwise. In general, it is very important to prevent and handle errors, and some case-specific error handling was used throughout this program. In some data analyses, it's important to clean the data to ensure the appropriate fields are consistently named and used. In this data analysis, data cleaning was not a core part of the project, as data was found to be consistently cased and spelled across the relevant fields. Instead, this allowed for more time and other resources to be used for the actual transforming and processing of data. It's worth noting that the programming language and modules used for this data analysis are cited at the bottom of this page. For this data analysis, we used the Python programming language and three of its supporting modules, Pandas, NumPy, and Matplotlib. APA references for these cited works are available near the end of this presentation. We now move on to question 1. What are the three most common types of traffic violations? This question and its solution look at the sample data's more refined categorization of traffic violations and compares the total number of occurrences for each of these violation types. To answer this question, we must first group records by violation type, then sum the counts for each type of violation, and sort these violation type counts in descending order. This has been done. In this slide, we are presented the solution to our problem, both in paragraph form and in vertical bar graph form. From the given sample data, it was found that the most common type of traffic violation was speeding, with 48,424 occurrences. The second most common type of traffic violation was moving violation, with 16,224 occurrences. And the third most common type of traffic violation was equipment, with 10,922 occurrences. Furthermore, this means that the most common type of traffic violation outnumbered the second most common type of traffic violation by about 298.4714%. Figure 1.1 on the right contains a vertical bar graph showing the three most common types of traffic violations. This graph is measured in thousands of occurrences. In this slide, in figures 1.2 and 1.3, we're provided snips of the relevant sections of source code that yielded the solution and vertical bar graph for question 1. If you have any questions about this source code, this particular question, or any other details of this data analysis project, please contact me via the methods provided at the end of this video. Again, my name is Tyler McDonough. This question and its solution look at the sample data's driver gender category and compare the frequency of each driver gender across the sample records. Although gender is included in this category's name, this field more accurately denotes driver sex, as the only values included represent male or female, for example, M or F. To answer this question, we must first group the traffic stop records by driver sex, sum the counts for each driver sex, and calculate and compare the frequency of each driver sex. This has been done. In this slide, we're presented the solution to our problem, both in paragraph form and in pie chart form. From the given sample data of Rhode Island Police Department traffic stops, the most common driver sex stopped was males, with that sex of driver accounting for approximately 72.5270% of stops. The second most common driver sex stopped was females, with that sex of driver accounting for approximately 27.4730% of stops. Figure 2.1 on the right contains a pie chart showing the percentage of traffic stops by driver sex. In this slide, in figures 2.2 and 2.3, we're provided snips of the relevant sections of source code that yielded the solution and pie chart for question 2. If you have any questions about this source code, this specific problem, or any other details of this data analysis project, please contact me via the methods provided at the end of this video. Again, my name is Tyler McDonough. We now move on to question 3. Rank the districts by number of traffic stops. This question and its solution look at the district category of the traffic violations in the sample data and the total counts for each type. To solve this problem, we must first group records by district type, then sum the counts for each type of district, and sort these district type counts in descending order. This has been done. In this slide, we're presented the solution to our problem, both in paragraph form and in vertical bar graph form. From the given sample data, it was found that Zone X4 led the Rhode Island Police Department's districts in total number of traffic stops. Zone K3 was second. Zone K2 was third. Zone X3 was fourth. Zone K1 was fifth. And Zone X1 was sixth by number of traffic stops. Figure 3.1 on the right contains a vertical bar graph showing the Rhode Island Police Department's districts ranked by traffic stop count. This graph is measured in thousands of occurrences. In this slide, in figures 3.2 and 3.3, we were provided snips of the relevant sections of source code that yielded the solution and vertical bar graph for question 3. Again, if you have any questions about this source code, this particular problem, or any other details of this data analysis project, I'm happy to help. Please contact me via the methods provided at the end of this video. Again, my name is Tyler McDonough. To recap, through this Python data analysis of Rhode Island Police Department traffic stop records, we found that across the sample data, the most common types of traffic violations were speeding violations, moving violations, and equipment violations. we found that males are the drivers in approximately 72.5270% of the sample traffic stops, and the Rhode Island Police Department districts ranked by total sample traffic stops are the Zone X4 district, the Zone K3 district, the Zone K2 district, the Zone X3 district, the Zone K1 district, and the Zone X1 district, respectively. In addition to the summary of what was found in posing and answering these three key questions, we have also included considerate follow-up recommendations now that the results of the data analysis are known. It's worth noting that this data analysis was done at no cost to the Rhode Island Police Department. It was completed with the hope that the resulting information will be used to help the Rhode Island Police Department better understand their traffic stops so that they may better allocate resources and prevent crime moving forward. Examples of possible solutions, now that the results of this data analysis are known, include preventing speeding through physical deterrents such as speed bumps, increasing male education on traffic laws and their collective contribution to traffic violations, and increasing driver education programs in the Rhode Island Police Department districts that encounter the most traffic violations. This slide contains our references cited for the works used in this data analysis, the Python programming language, and its supporting modules. All of these resources are free to use at this time, and each of their websites have their associated installers and good documentation. Lastly, here's the contact information for me, Tyler McDonough. I'm an honors computer science student and work to exercise that science to help computers better meet the needs of people and help people better use their computers. Please contact me by email at tylersmcdonough@gmail.com or by phone at 937-477-2225. Happy computing, thank you for watching, and have a great day.